Assalamualaikum warahmatullahi wabarakatuh. This video is the second part out of 4 parts related to the idea of one sample sign test. And in this video, I'm going to talk about the general procedure of how this test can be conducted. So basically, let's say you are interested in studying the population median, M, then you can use the non-parametric procedure, for example, one sample sign test. Now, let's just have a quick recap here. When you talk about median, median is just a middle value that you get once you have arranged your data in order of magnitude, of course, from lowest to largest value. And in this procedure, in one sample sign test, it is also known as sign test and very easy to be conducted because you are just dealing with having plus and minus signs. Okay, so that's all that you are going to do. You are going to convert your numerical data into plus and minus signs. And how are we going to achieve this? Well, before we can talk about the process here, let's talk about the assumptions that you need for one sample sign test. And the first one is it requires our sample to be a random sample of independent measurements from a population. Doesn't matter what population is, doesn't matter the distribution of the population here, and we are just going to assume that population has the unknown value of median. Okay, so we denoted that with M. And this procedure can be used when you have data as simple as ordinal data. For example, you can use it if you have ordinal scale measurement or interval or ratio. So the least scale is ordinal scale. Then, and finally, we assume that the variable of interest is continuous. So that's it. That's pretty straightforward assumptions. And when you want to study the population median M, there are 3 possible scenarios that you can consider. For example, this one here is H null M is equal to some specific value of median, whatever number it is, doesn't matter. So it says here our unknown population median is equal to a specific value, whatever number that will be given here. So H null here will be contested against the alternative hypothesis, which is M not equal to M naught. So that is the first scenario. For the second scenario, we will have a complementary alternative hypothesis. Clearly, it's going to be M greater than M naught. And finally, this particular null hypothesis will be contested against this alternative, which is M less than M naught. And just make sure that the pair given here, they are all complementary in nature. Okay, so how can we obtain the test statistic for one sample sign test? Let's say you have a data set with measurements represented as such. So this is your first value of your data set, the second value, and the nth value. Therefore, your data set here has n observations. And here is the sample size. Okay, in other words, this is the sample size. And the process is very simple. What you need to do is you need to find the differences of your data set. Each of your data value will be subtracted with the value of null hypothesis M naught. So M naught over here will be used at this part. You will subtract m0 from your data set here, and you will get the difference. So the point of interest that we are concerned with right now is not the differences per se, but we are concerned with the sign of the differences, either positive or negative. So that is what we are going to focus on. Now, how can you obtain the test statistic for one sample sign test? Now, the test statistic here, bear in mind that the test statistic is different for different case of scenarios here. For example, if you have a null hypothesis as such, then you are concerned with the number of positive signs. All right, so you are going to count how many positive signs that you observe after you have consider the differences given here. Okay, so that's the idea, and you will choose a different test statistic. For example, this one, if your null hypothesis looks like this, and for this case over here, you need to choose the smaller number of either positive signs or negative signs. So whichever is smaller, that will be considered as the test statistic for this particular scenario here. Now, don't worry too much about this, because I believe that when you have seen the example, which I'm about to do next in the next video, so you will be able to understand the process here with better clarity, I hope. Okay. Now, here is the decision rule for one sample sign test. Basically, you are going to decide whether the null hypothesis can be rejected or not based on these particular rules given here. And this rule here require the use of binomial probabilities, where I believe a lot of resources are available online. And as an example, you may want to visit this website to obtain the binomial probability table, the table of binomial probabilities. Okay, so let's talk about this scenario here. When you have this particular null hypothesis of interest, then you will reject H null at level alpha if this is observed. So basically, you will reject H null if the probability of observing as few or fewer plus signs, okay, you're talking about plus signs because this is the test statistic related to the particular null hypothesis given here. So the probability of getting few or fewer plus signs in a random sample of size n when H null is true must be less than or equal to alpha. So reject at level alpha when this probability here is less than or equal to alpha. Okay. So for this one here, okay, that will be finding the probability of observing as few or fewer minus signs. So you're talking about minus signs. Again, it is related to this idea here. We see that in this scenario, the test statistic is related to the number of minus or negative signs. And if this probability is less than or equal to alpha, then you will reject H null at level alpha again. Now, for the last scenario here, notice that you are not dealing with alpha, but you will have to divide alpha with 2. So alpha over 2, because here you have a two-sided test. Okay, you have a two-sided test, for this kind of null hypothesis. And because of that, your alpha has to be divided by 2, and it follows the same idea. Basically, you are going to find the probability of observing few or fewer. Okay, what is the meaning of this? The less frequently occurring sign. So what it means by this is, now we go back to our test statistic. Notice that our test statistic is related to choosing the smaller number of either positive signs or negative signs, and because of that we are focusing here at the less frequently occurring sign. Is it positive? Is it negative? So we are going to consider the smaller number of those signs that are occurring in a random sample of size n. Obviously, when h0 is true, has to be less than or equal to alpha over 2. So notice that we are always concerned with this probability being less than. Okay, so being less than, a significance level over here must be alpha, because this is a one-sided test. This is also a one-sided test, so alpha here is maintained as the given significance level. But for this one, this is a two-sided test, therefore alpha here has to be divided by 2. So that's the idea. Now for this one, how to find the probability described in the decision rule? So as I've said just now, you need the table of binomial probabilities. But why is that? Because in this pool of data set, our sample is actually consist of positive and negative signs. Now recall what is the idea of binomial distribution. The binomial distribution comes from having a random variable with just two values, right? Dichotomous values, in other words. So when you just have like two possible options like that, and if the null hypothesis is true, what is the null hypothesis? The null hypothesis is saying that median is equal to m naught, and you know that the median is the position of value that separates our data into half, okay, into half. And you expect that when the null hypothesis is true, the sampling distribution of the number of differences yielding the sign of interest is a binomial distribution with this parameter. Now, why is that so? Because when this is the position of m naught, of course, values that are on this side are the values that are lower than the position of m naught, and this one here are values that are higher than the position of m naught. So when you consider finding the differences, this value here will give you the differences with minus signs, and these values here will give you differences with positive signs, obviously. Therefore, we will expect that the probability of getting that will be 0.5. So this is the binomial distribution with parameter p 0.5. P here is the probability. And because of that, again, we will need to find the probability here from the table of binomial distribution. Look out for p 0.5 with an specific value according to whatever your sample size is. Okay, right. And here will be k is our random variable. The random variable here is the number of signs of interest. Like I said earlier, the number of signs of interest here is different according to different hypotheses that you are concerned with. So it has to follow the hypothesis given, because the signs of interest are different from case to case. So here, the signs of interest. Okay, so here is the observed value of test statistic. Again, it depends on the hypothesis that you constructed in the first place. Therefore, this is the statement of probability. Okay, we are seeking to find the probability k being less than or equal to k when you have a specific sample size with size n, and the probability of getting that is 0.5. And I have already explained why it is 0.5, and it is based on this simple diagram given here. So I hope you already understood why the probability has to be 0.5. So this simple mathematical expression here can be translated as probability that our random variable here, k, less than or equal to test statistic, small k, given a random sample of size n from a population in which the proportion of signs of the specified type is 0.5. So that is another way of translating this statement here. But this statement here is just the same thing as what we are doing at this part. So it is actually this part here. It's the same thing, just that the statement is slightly expressed using different words. Okay, but basically this statement, for example, is the same idea with this one. Okay, I think that's all from now. Thank you very much, and I will see you in the next video with an example to illustrate this one sample sign test procedure. Okay, thank you very much for watching.